So basically right now on stage we have Jewell from Alteryx. It's a slight alteration of the presentation. So this one is called managing the analytics life cycle instead of the one that is written in the agenda. But it's pretty much similar and it's even more cooler, right, Nick?
If you've come for the hockey, come back at 2:45 to the Alteryx booth. We'll take you through all of the good stuff there. Thanks, Goran.
Start.
Right, I'm just going to set my timer. Perfect. Hi, everybody. Thank you very much for attending today. As Goran says, managing the analytic life cycle, I'm going to be using a couple of buzzwords that are in the industry. So citizen data scientist and model factory. I don't particularly like to use the buzzwords, but I want to explain model factory in this context. So data scientists moving models into production, operationalizing advanced analytics and insight. We're talking about automation, we're talking about test-driven development, and we're talking about then embedding that content automatically into products and services. Now, the focus of the talk today is really going to be around three main areas, and I'm going to watch the time really closely to make sure I cover them all. First of all, I'd like to go through my experiences of building the modern analytic playbook. So those are those key steps, those key muscle motions that an analyst and an analytic leader needs to go through to succeed with analytics today. I want to talk about fixing a disconnect that exists between data scientists, data engineers, and the wider line of business audience. And then finally, I'd like to give you my thoughts about how I see analytics evolving in the future. So first of all, a little bit of positioning from an Alteryx perspective. So I want to show you where we see the market today and where we see the market going, let's say in the middle of the next decade. So over on the left-hand side, there are just not enough data scientists to go around. Now, we do see heavy investment in applied mathematics, statistics, engineering disciplines. That means the number of data scientists will grow over the next decade, potentially doubling, but we don't see it tripling or beyond. We don't see a hockey stick growth at this point. Now, we do see a large number of business users consuming interactive dashboards, reporting. They're starting to really embed data-driven decision-making. But we see this group in the middle, currently using advanced spreadsheet tools. Maybe they're building macros in VBA. Maybe they're hacking in SQL against some of your large databases. And this is really the audience that we target. These people are going to become the citizen data scientist in the next decade. And this means that they're going to be using a data science platform to ingest, explore, model, and grow their data and their insight, publishing it out to a wider audience, and working in partnership with that existing data science capability. So if I was to describe to you what an analytic playbook looks like, in very simple, broad brush marketing terms, it looks like the diagram on the screen right now. 4 key areas that I'm going to walk through purely in terms of capabilities. We don't need to talk product names. Come to the booth afterwards. We can tell you how we do it. Many of the other vendors will tell you how they do it. But I want to give you our impression of the important capabilities in this space. So first of all, discovery, sharing of knowledge, understanding where your assets lie as an analyst across your business. Let's take a closer look. So first of all, we may have data residing in local files, network shares. Data can be absolutely anywhere. As companies move more towards the cloud, we start to see object storage coming into play more and more often. Amazon S3 as an example. This starts to fill with documents and with data, and your analysts need to be able to find that data, whether it lives in a relational database, maybe a BI server, maybe indeed in the cloud inside applications like Salesforce. Providing all of that through a simple-to-use analyst interface, a Google-like search experience, if you like. Once you've found what you're looking for, let's talk about context. So we might want to understand how data flows from that cloud database into a report or a dashboard. Beyond this point, we found what we're looking for. We understand its place in the world. How do we know as analysts if we can trust that data? So we might take the approach of something like TripAdvisor in the public world, a thumbs up or a thumbs down, based on how an analyst finds the usability and the usefulness of data. It also might be more from a chief data officer and their organization pushing down official certifications, or maybe saying, this is not an approved data source, this should not be being used. We can also ingest data dictionaries, business glossaries. And that's really important because this intelligence, this tribal knowledge that exists in an organization is generally quite spread out. We need to bring it together and associate it with the assets that analysts need to use. So all of this feeds back in a kind of virtuous cycle, if you like, back into the search results, back into the discoverable platform for the analyst to make better decisions. And this isn't a one-off process. You'll see on the left-hand side, we acquire data from all of these different sources on a regular basis. So regularly updating exactly what the enterprise owns, where that data is based, how to understand and trust that data, and repeatedly bringing it into a search process. The next step in the playbook, probably the most critical for the audience today, that pure engine of ingestion, data preparation, analysis, modeling, and explanation of the models that you produce. I've got a pretty simple graphic on the screen that I'd like to show you. Really showing on the left-hand side all of the data sources that an analyst might work with on a day-to-day basis. So this could be everything from a data warehouse, a data lake, we could be connecting to cloud applications, or indeed web services. Analysts today frequently work with 5 or more data sources just to produce a single piece of insight. And that data literally can come from all of those sources I've already mentioned, local mapping files in CSV or Excel, semi-structured data, JSON, XML. It's such a variety, and the analyst has to deal with this on a daily basis. Building visual, repeatable workflows, crucially without code, so they're easily transferable and easily understood. Enriching the data from a number of different sources. Let's say you have location information, customer addresses, for example. Let's use tools to unlock that data. Geocode, maybe calculate drive times or catchment areas using partner data from companies like TomTom, or maybe service APIs. Once you've brought all this data together, we want to be able to analyze it in a single pace as part of a train of thought analysis. And this is where we drop in tools such as R or Python and get the ability for users to actually consume models that are produced in those languages without having to write or interpret that code directly, making it as friendly as possible. You generate your insight. What do you do next? Do I need to rewrite it in a reporting or a dashboarding tool? In a single visual workflow, we produce output that can then be shared into popular formats like Tableau, Click, Power BI. If you need to publish to PDF or Excel, that's also possible. But we see the democratization of data and self-service really coming into its own when you take a workflow and you publish it as an analytic app, making it available to non-technical business decision makers. This frees up the analyst from having to continually tweak their analytic pipeline to get on and do higher value work. Now, the final step that I'm going to talk about in the playbook is once you've produced that insight, how do we deploy? We've just mentioned we publish out to Tableau. That's probably the most basic form. Getting a dashboard, getting a report, lots of different vendors supported, but crucially producing something for onward use in a different tool. What about if we built an analytic model? Let's say we want to work with one of our partners like Teradata. We want to take that model, we want to put it down inside their data platform and have it run at scale in batch mode against potentially millions or billions of records. That's another deployment pattern. The final deployment pattern, potentially the one with the greatest value, is where we take an analytic model and deploy it directly inside a business process or a business product. I'm going to give you an example from, again, the real world. Take Netflix. You open up Netflix on your smart TV, Netflix immediately gives you recommendations on what to watch. So we're talking next best action, prescriptive analytics, recommender systems. This type of instant feedback to the user in the middle of that business process, absolutely invaluable and helps them capture more market share. And we'll be talking about that more in a moment. But for now, I just want to give you those key capabilities that we see in a modern analytic platform. Discovery and sharing, preparation and blending, analysis and modeling, and then deployment of insight and management of the subsequent models, all wrapped together with a growing community of interest, making sure that community is tied into the platform at each possible step. And being a platform, we really talk about this being a two-way market. We talk about activating the community to make sure the community can contribute at each of these points, opening up through APIs, software developer kits, the community creating new tools and making these available in an app store style marketplace. All of this available for a really vibrant platform. Now, for a couple of minutes, I'd like to take you through a walkthrough of what a platform might look like in action. So on the screen, we're starting off in a social data catalog. We're searching for assets, getting feedback on those assets, looking at the data dictionary content, looking at certifications from a chief data officer, or that informal thumbs up, thumbs down reputation. From here, we might want to go and have a look at how that data is connected. We talk about an interactive metadata map we call the nexus. Everything's interactive. We can engage with the community, ask questions, get responses from experts, no matter what division they're in. Let's say we want to go and explore a particular workflow, and we want to go and dive into more detail. We'll go and search for it at the top of the screen, dive into content harvested from across your enterprise, opening that content and taking you directly to that user-friendly web front end. The ability to automate built into the platform. I want to schedule on my basis. I want to do it on a Monday or the last day of every month, whatever's needed. I want my end users to be able to interact with that content without me having to tweak my work. So they can enter parameters on the screen, run analytic workflows on demand, and start to explore the results, spatial results in this case. Now, I want my platform to be enterprise ready. So I want to be able to use features such as version control built into the product, as well as enterprise scalability, allowing me to grow as my user base grows. Here you can see, for a line of business analyst, being able to pull that model down under version control, and then start to be able to explore data profiling, data quality, using what we call inline visualytics on the left-hand side. Preparing the data, parsing, summarizing, enriching the data to produce a perfect analytic data set that can be blended together, fuzzy matched, looked up, joined together, whatever's needed. Enriching with spatial, but then also bringing in additional tools, the ability to work in memory, the ability to work inside a data platform. When you start to get to the terabyte scale of analytic operation, partnerships with these vendors becomes all the more important. Connecting to REST APIs. Come and see the hockey talk this afternoon, and we'll talk about connecting to structured data via a web service. You want to bring in Google Analytics, Marketo, Salesforce. No code needed, simple configuration. We can talk to our community. We can see additional tools that have been built. We can download and incorporate those tools directly within our workflow in a matter of clicks, producing visualizations, producing outputs to all of these popular formats. The key is flexibility. The key is openness and transparency when we talk about a platform. Let's drop in a publish to Tableau server tool. And again, one click, your data set is available as part of our partnership agreement, as part of our platform ecosystem for further use. Similarly, code-free, we'll drop in advanced analytics. We'll build a model, we'll get sound insights with respect to that model. We can iterate rapidly as analysts, and we can really understand our data. And with one tool, we can click and deploy that model to wider use as part of an analytic utility. So let's talk about that analytic utility. Let's talk about how data scientists work in the world today. And there is that real disconnect between data scientists over here on the left-hand side, typically coding in R or Python, maybe Scala. They iterate with their experiments, they engineer features, they produce and test their models, the data science lifecycle. And once they've produced their models, well, hey, what do? Of course, they throw it over a wall to some software engineers, and they say, guys, it's your problem now. Please implement this across our systems. And the data engineers, the software engineers say, I don't know what to do with this. This is not in an enterprise language that I understand. As an engineer, I might be working in Java. I might be working in C++. I might be working in .NET tools. In short, the language disconnect here can be a real problem. Go to stackoverflow.com. Search conversations around how do I build a boosted model in Java, and look at the hundreds and hundreds of replies. This is not a trivial problem. And this is not even the end of the problem. The data engineers still need to get this model and its insight deployed to users and applications. So as part of our conversations with customers, as part of our deployments in the real world, we actually found that fewer than 30% of data science models actually make it into production. What does this actually mean? The models stay in sandboxes. They stay on data scientists' laptops. This is the extent of all of that investment that you're putting into your data science groups. The models never get actually properly used where they're required. And let's talk a little bit more about some of those blockers. So first of all, the expertise bottleneck. Prior to joining Alteryx, I worked for a very large bank, very much under change control when it came to IT processes. Lots of instructions about how far in advance you had to set up your release schedule, get everything ticked off by potentially hundreds of different individuals to get something live. I'm sure you know the experience. What happens with models is exactly the same. What are the steps needed to deploy to production? Is it different for someone in an organization who previously works with Java, and it's a very known entity? What happens when you have R or Python? Do we need whole new processes to get content live? And secondly, congratulations if you do actually get a model into production. But why does it take so long? And who looks after it if I need to deploy a new version? What if I need to roll back for some reason? What if I've detected a feature that's unstable or is giving incorrect results? How hard is it to actually manage that process of model management and version control? And this is for a single model. What happens if I have 3 models, or 10 models, or 100 models? And then finally, naturally, over time, customers' models are going to degrade. They're historically trained with data. That data is not always representative of 12 months into the future. So we generally operate on a system of champion and challenger. The champion model is in production. There is a suite of challenger models behind the scenes biting at the ankles of the model in production. At some point, that challenger model will overtake the champion, and that's when we need to switch those models over. How do we quantitatively identify if that's the right process? How do we know if the new model is better? So 3 simple problems, very, very difficult problems actually, but we found that single data science deployments can cost over $250,000 to deploy. We're talking about a data science deployment process that we've seen that can take up to 15 months just to get a single model into production. 3 ways we can enable the solution. So as part of our platform, it's code-free or it's code-friendly. You saw we drop tools into a workflow and we can get results without having to script. But for those data scientists working in R or Python, let's get open source libraries on their side. Let's get it in the environment of their choice, maybe RStudio, maybe a Jupyter notebook, and we can get models deployed directly from their environment. Secondly, when it's this easy to deploy, we can start to do it many times, potentially every single hour. We're almost talking about continuous integration of data science models, that model factory concept that we talked about earlier. And when it's this easy to deploy, it's much easier and much cheaper to experiment. And finally, your model's in production. How about monitoring the results? How about understanding the parameters where a model succeeds and where a model fails? Google the Netflix challenge if you want to understand how data science teams came together to produce a 10% lift on their recommender systems. But within a platform, we need to make sure it's really easy to evaluate these models side by side and know when we swap one out for another. So let's take a look at that model factory in action. At the top of the screen, code-free, developing in a visual, repeatable workflow. Down at the bottom, code-friendly, working in the languages that data scientists choose to work in, all of which can be automated using a wider, open analytic platform. These models get deployed using a technology called Docker, a container technology containing everything that the model needs, an incredibly elegant approach to model management and version control, and providing an API endpoint which your software engineers can then embed in applications, can provide to customers, can provide to frontline employees, exactly whatever is needed. Now I'm going to leave you with a couple of slides. First of all, the idea that analytics is a continuum. We firmly believe that data preparation and blending, lowly data prep, is still the foundation of modern analytics. Now, the industry as a whole has been absolutely fixated on the idea of interactive visualization for probably the last 4 or 5 years. We're still going to call this descriptive analytics. It's still only step 2 in the journey. Tell me what happened and make it look pretty. As you can see, many more steps get unlocked once you have a platform that enables users with domain expertise to really get engaged with analytic content. So to finish up, to talk about the evolution of analytics and where we see us going next as an industry, as a market. Let's talk about that analytic utility. Let's take an API endpoint and start to incorporate it into some of the other analytic utilities available in the world. A lot of you have probably seen Alexa demos at various conferences. I'm going to take another Amazon product called Amazon Lex, a chatbot technology, and I'm going to show how using natural language a user or a customer can interact using a promote model directly within the business process. I'm using natural language and I'm filling in the parameters needed to score a predictive model that's been deployed serverless within the Amazon cloud. So you can see I'm literally using very informal English and I'm getting a score directly back on the screen. So for me, the future, the evolution of analytics is making sure that our platform becomes a utility and can be consumed as such. So thank you very much.
Thank you, Nick. Yeah. Does anybody has a question from the audience? I can run. Any questions at all? No? So let's start with one. You're describing quite a lot of things that you should, an organization should do. But let's turn it around. What are the don'ts? What is the completely opposite way of starting things, which is basically on the end lead to some kind of a failure when you establish analytical?
So an anti-pattern, if you like.
Yeah.
Okay. So the biggest anti-pattern that I've probably seen is the squirrel and the acorns. So this is where maybe it's IT driven, so it's not directly tied to a business process. IT gathers all of those acorns of data sources and puts them inside a lake without proper consideration of their business purpose. Analytics needs to be driven by a business process or a business challenge that can be gripped by the analysts themselves and if developed by data scientists. If it's purely IT-led, it won't have the focus. You build up a data lake, you build up a repository. Without good thought, you don't get ROI. Analytics provides the ROI on that vast reservoir of data.
Thank you, Nick.
Thank you. Thank you, everybody. And at 2:45, come and see Hockey and Analytics, which you would have seen now.
Yes, thank you.
Thanks a lot.